Hi guys, I want to do a demonstration for you to show the relationship between objects, their different coefficients of friction and the angle of inclination. So this is kind of a precursor or a demonstration to go with the proof that I showed you today in class, the relationship between theta, the angle of inclination, and coefficient of static friction. All right, so I'm going to start out with this object here. It's just a bronze brass mass, 500 grams. I'm going to set it on here. And right here what I have is this is a gravity protractor, and it's showing you the it's actually showing you perpendicular to the surface what that angle is. And right now, this is always going to point straight down. So basically, this is going to point in the direction of gravity. And we're going to see what angle that actually is making with the surface. So basically, this is always our hypotenuse. This is always the direction of gravity. And then we're going to see how that angle changes as I'm lifting this up. And so let's see if we can figure out at what point the object starts sliding. At what angle it starts sliding. Okay, so right here is where it starts sliding, and now it's run into some tape. I can't go any further. And so right about here, so wherever I can catch it. Okay, if I can look at that, it looks like we were right about at 10 degrees. For the gravity protractor, it reads straight down at 0 degrees. So at about 10 degrees of inclination, this thing was actually sliding down. So a very, very small amount. And then we can actually use our equation relating the angle of inclination to coefficient of friction to find out what that static friction was, the coefficient of friction for this object. So now, let's try a couple different objects. See if we get some different angles of inclination. I'm going to try my cell phone. So it's got kind of that rubbery case on it. And I'm going to try sliding that down. And let's see what angle we get to. All right, looks like we're definitely getting higher than the last one. Okay, so right here, and I'm going to rescue that before it goes. And if I can reach up, grab that. All right, looks like we got to about 25 to 27 degrees on that one, so quite a bit more. So what does that tell you then about the coefficient of friction? Is it greater or is it smaller? Okay, now last one I'm going to do. Remember the old tape dispenser from my last friction demonstration? See how high we have to go before the tape dispenser starts sliding. Pretty high. Oh, I think here we are. Oh, just barely. See, it's just barely moving. But it is going. Okay, and that was all the way up at 40 degrees. So quite a bit of inclination there. So notice that what's happening as I lift this up, the amount of friction that's acting on the object is decreasing. And that happens because the normal force that the surface is having to apply gets less and less. Because when it's acting at a higher and higher angle, normal force can't push straight onto the object as much because part of that force is pulling it down. So when we get all the way to, well, unfortunately I can't get all the way vertical here, but if it goes all the way vertical, then we know that, see, look, it says vertical. If we, then that shows me, well, yeah, right about here. Step sliding. Then when it's straight down, then the object has absolutely no normal force acting on it at all. So I can even put this right here, but there's no normal force. It's just going to go straight down like an object in free fall. So as the plane is lifting up higher and higher, less and less normal force is acting on the object itself. All right, and now let's go and take a look at the math.